want to do a quick review of the two definitions of the derivative that you really need to know. Now, obviously, we know all kinds of shortcut rules for derivatives, and that's great. It's going to be all over the AP exam and would be all over any college course you take as well. On the multiple choice, we usually ask a couple of questions to see if you know the limit definition of a derivative. And I have a feeling they could possibly work that kind of thing into a free response question, since obviously they can't ask it in multiple choice questions anymore. So remember, a derivative is really the slope of a curve. And remember, the way that we do this is you've got some kind of a curve, and you say, all right, I've got a point here, and I'm going to pick a point really, really, really close to it. So a lot of times we say, well, okay, we have some constant, maybe this is the point 8,2, okay? So we say we've got some constant, and we have the functional value at that constant, okay? And then we pick a point real close, and usually it's like a 10th away, or a 100th away, or a 1,000th away, something like that. I'm going to make it look a little farther away just so we can see what's happening. And a lot of times we'll give that a variable value, okay? It's an x, and whatever the functional value is at x, so x f of x, okay? And the idea here is if you find the slope between those really two close points, it's going to be really close to the slope along the curve at that particular point. Okay? And the idea here is as these points get closer and closer together, in other words, as this x value gets closer and closer to the c value, the slope's going to get better and better and better. And that slope that it's approaching, as you pick numbers that are closer and closer, is the actual slope, is the actual instantaneous rate of change, which we now call the derivative. So remember, the derivative is a limit of a slope. Okay? It's just going to be the limit as x approaches c. In other words, as this x gets closer to that x, of the slope. So y2 minus y1, that's f of x minus f of c, all over x2 minus x1, that's x minus c. Okay? In general, if you see a limit and you see a fraction that's got two differences there, it's called a difference quotient, it's probably the limit of a slope. It's probably a derivative question. Okay? And you may not necessarily be evaluating it using limits. You may be able to use your shortcut knowledge about derivatives now just to go ahead and evaluate it. Okay? So that's one definition. Okay? So let's look over here. We've got two examples here that look like this. Okay? Now it's a super simple graph. They may give you something more complicated. But here's the point. Okay? If you look at this and you say, I see the limit of something that appears to be a slope. Oh, they're asking me to find the derivative. Where? Well, this is the limit as x approaches some c value, some point where they're asking you to find the derivative. So they're asking me to find the derivative here at 1. Okay? That's all they're asking me to do here. Okay? This would be a graph of f of x. Okay? So basically what they're doing here is they're saying this is the point 1 f of 1. Okay? And then we'd be picking a point really close to that. We would call it x f of x. Okay? And if you found the slope would be f of x minus f of 1 over x minus 1. It would be that. Now, this is a really boring limit problem. It's a really boring derivative problem because, it's a straight line. Okay? We know the derivative of a straight line is really just the slope. Okay? So you wouldn't actually use limits to find the slope normally, but the point is that's what's happening. So anyway, you should just recognize, oh, they just want me to find the derivative of this function at 1, okay? And you can just find the slope there. It turns out the derivative of this function at 1 is just equal to 1, okay? So notice, I never found a limit here, okay? I didn't use a bunch of limit rules. I don't even know the equation. Well, I could write the equation, but they don't expect you to write the equation of those lines, okay? Down here, same thing. It's the limit as x approaches 3, and you see, oh, it's the limit of a slope, and they've subbed in 3 for the c value. Oh, they want me to find the derivative of this function at 3, okay? And we go up here, we go to x equals 3, and I don't have all the points here, but I think this is a horizontal line. They'd give you enough information on the AP exam to tell. So it's a horizontal line, the slope is 0, okay? Now, you may see a second fraction that kind of looks like a slope, but maybe not quite as much. It might have h's in it, or delta x's, or something like that. That's the second definition of derivative, which is actually more common in most courses, although on the AP exam they use these pretty interchangeably. Okay, the other limit definition of a slope, remember, that one that we had required you to have a point. Okay, the second one gives you a derivative equation, which is a little bit more useful, what we use most of the time. That concept was you start out at a variable point, call it x f of x. And if you remember, we go over some horizontal distance. We call that h, okay? And we pick another point that was real close, okay? So the x-coordinate is x plus h, and then we're taking the functional value at x plus h, okay? And we're finding the slope of the line that goes through there. And as those points get closer and closer together, in other words, as h gets smaller and smaller, the slope gets better. So we say it's the limit as h approaches 0 of the slope. y2 minus y1 would be f of x plus h minus f of x all over x2 minus x1. X plus h, if I take away x, leaves me with just h. Okay? Now, you may see different notations here. They don't always use an h. It's actually a change in x. So some books will use a delta x, and they'll say as the change in x approaches 0, and they'll say, you know, they'll have a change in x on the bottom, and they'll have a change in x right there. They're just saying, hey, you're going to one point, and you're going over a little bit in the x direction, and you're picking a second point, and you're finding the slope and seeing what it approaches. Okay? Anyway, I'm going to go back to h notation here. This is the most common. But anyway, so you look at the second one, and you go, oh, yeah, we got the h approaching 0. It kind of looks like a fraction, almost looks like a slope, but the denominator is a little bit simplified. Oh, they want me to find the limit of a slope. That's a derivative, okay? Now, here's one thing that will occasionally throw people off. And obviously, we're looking for f prime, but like, where am I looking for the derivative, okay? Notice the definition here, you have the x value there. They've replaced the x value with 2. Okay, so they want you to find the derivative when x is 2. In other words, they're starting at the point where x is equal to 2. So instead of 2 f of x, instead of x f of x, they are starting at 2 f of 2, and then they're going to this point over here. And so that would be 2 plus h, and that would be 2 plus h right there. And that's how you get the equation with a 2 there instead of an x. But you're just taking the derivative at 2. Okay, now notice something. That's a cusp, okay? Because there's a cusp, we're approaching a derivative of one slope from one side, we're approaching a derivative from another slope on the other side. There's no overall derivative there. So basically we say there is no derivative, it's not differentiable at a cusp, something like that, okay? Now you may see this with functions as well. You might see something like, the limit as h approaches 0 of sine of x plus h minus sine of x all over h, okay? And again, you should say, kind of looks like the limit of a slope. I wonder what function they want me to find the slope of, because I know the limit of a slope is a derivative. And you can actually see the original function right here, okay? So this is really just asking me to take the derivative of the sine function, and again, if you try to do it with limits, you're probably going to mess it up. But anyway, we know what the derivative of the sine function is. It's just cosine of x. Or if they did something like this, maybe they would do the limit as h approaches 0 of sine of pi plus h minus sine of pi, something like that. Notice the x has been turned into a pi. So they're asking me to find the derivative of the sine function when x is equal to pi. And so anyway, we would find the derivative, it's cosine of x, and then we would substitute in pi there, and cosine of pi, I'm trying to think about what that looks like. Let's see. It's going to be -1, I think, would be the final slope. Okay, so a couple things there that we know, but we maybe haven't seen them in exactly that form. But look for those. Very common on the AP exam.